In this example, we're going to take a look at the functions f, which is the square root of 10 minus 2x, and g, which is 1 over x plus 2, which we saw in the previous example, and think about how we can find the general expression when we combine these two functions, for example, when we add them in part A, and then think about, well, what values of x are we able to plug in to these different combinations of f and g. So writing out an expression is fairly straightforward in that we just take the expression for f of x and we add to it the expression for g of x in part A, since part A is f plus g. So the expression that we get, f plus g of x, therefore is equal to f of x is the square root of 10 minus 2x, and g of x is 1 over x plus 2. And that is about as simple as we can write it. And so now let's think about, well, what values of x make sense to plug into this function? What's the domain of this new function? And so the only way that we're going to get an output of this function is if I take a value of x, which I plug into f, and I get an output from f. So in other words, the square root of 10 minus 2x gives me a defined value, and I take that same value of x and plug it into g, 1 over x plus 2. And as long as I take a value of x and I'm able to evaluate both f and g, then I'm going to be able to add those values together. So the domain of this combined function is going to be the intersection of domains of f and g. So we can think about the domains of each of these functions separately and then think about where they overlap. So taking f, which is the square root of 10 minus 2x, we just need to make sure that the expression under the square root, which is 10 minus 2x, is not negative. Okay, we can't take the square root of a negative number. So I'm going to think about all values of x that give me something greater than or equal to 0. So as long as this is satisfied, then whatever I get when I evaluate 10 minus 2x, I'm going to be able to take the square root of that number. So solving this inequality, we get minus 2x is greater than or equal to minus 10. And now I can divide both sides by minus 2. And just a caution, remember when we divide both sides of an inequality by a negative number, by something such as minus 2, we need to change the direction of the inequality. So this tells me that the domain of f is all values of x which are less than or equal to 5. For the domain of g, here we have a fraction. Okay, and the denominator of this fraction is x plus 2. So I need to make sure that I'm plugging in x values that are not going to give me a 0 in the denominator. Any other x value is going to be fine to plug in. So the domain is going to be all values of x such that the denominator x plus 2 is not equal to 0. So that tells me that any value of x which is not equal to minus 2 is going to be a value which is in the domain of g. Okay, so we found the domain of each of these functions f and g separately, and now we need to think about where these domains intersect, where they overlap. So here's a little number line for values of x, and I know that x equals 5, that's going to be a critical point. So we can mark that one on our number line. And the value minus 2 is also going to be an important point. So for the domain of f, we had all values that were less than or equal to 5. And for the domain of g, we had all values except for minus 2. And now we look at where these values overlap. So that's going to be all of these values over here, less than or equal to 5 and not equal to minus 2. So writing this out in interval notation, we get the interval that goes from minus infinity up to, but excluding minus 2, and then picks up on the other side of minus 2 up to and including 5. So there is our domain for the expression for the function f plus g of x. These are all the values that we can plug into both f and g. In part B, the expression that we get for the function f times g of x is going to equal the expression for f times the expression for g. So in this case, f times g of x is going to equal f of x, which is the square root of 10 minus 2x, times the expression for g of x, which is 1 over x plus 2. And so simplifying this, writing it as a single fraction, this is the square root of 10 minus 2x divided by x plus 2. And similar to the previous one, the domain of this function is going to be all values of x that when I plug into f, I get output which is defined, and when I plug into g, I get an output which is defined. So that's going to mean that the piece over here gives me a value, and the piece over here gives me a value, and so then I can multiply those two values. So it's going to be the same exact thing as the domain of f plus g, since that was the same analysis we needed to do in part A. So the domain here is also going to be minus infinity to minus 2 union the interval from minus 2 up to and including 5. Okay, so when we look at these combinations of functions, we need to think about the values of x that make sense when we plug it into each one. In part C, here we're going to get g of x divided by f of x is going to equal the expression for g, which is 1 over x plus 2, divided by the expression for f, which is the square root of 10 minus 2x. And so this, in other words, gives us 1 over x plus 2, and dividing by the square root of 10 minus 2x is the same thing as multiplying by the reciprocal 1 over the square root of 10 minus 2x. So writing this as a single fraction, I get 1 over the quantity x plus 2 times the square root of 10 minus 2x. And so now when I think about the domain for this last piece, there's an added thing I need to look out for. So I need to take values of x that when I plug it into g, I get a defined output. And when I plug it into f, I get a defined output. But notice, now that the function f is the denominator of a fraction, we also need to make sure that the denominator, in this case f of x, is not equal to 0. So we have an added condition to look out for here. So the denominator, square root of 10 minus 2x is equal to 0 when the expression in the underneath the square root is equal to 0. And we can solve this and get 5. Okay, so since the value x equals 5 makes the denominator, makes f equal to 0, we also need to exclude this value. So this value we need to get rid of. We don't want values of x that make the denominator 0. So in addition to the domain that we had for the combination of these two functions, we now need to get rid of this value 5. So that gives me an interval of minus infinity to minus 2 union minus 2 up to, but now excluding x equals 5. So there would be our domain. So to just summarize, when we're looking at the combinations of functions, we need to look for the intersection of the domains of each of those functions. In other words, we look at where those domains overlap. That works for A and B. And in part C, when we're combining these functions by division, we also need to take into account that the function that we're dividing by, in this case f, is also not equal to 0. And so in this case, we needed to figure out when is f equal to 0, and that was at 5, and make sure that we, in addition, exclude that point from the domain.